Welcome everyone to the first technical session of this year's 2020 ROS-Industrial Conference. My name is Dr. Bernd Karl from Fraunhofer IPA in Stuttgart, Germany, and I will be your host for the next 1.5 hours on software quality. Before we start the presentations, a few words about today's conference formats. We will have 2 presentations from 3 speakers, each about 20 minutes, plus questions and answers, followed by then the discussion round in the end. All of you following us at the conference website should have a live discussion box at the right of the sessions page. Please post any questions or comments you may have for our speakers under the questions tab in that box. I will read the posted questions to our speakers either directly after the presentation or at the final discussion round. In addition, you can vote on polls posted by our speakers. With that out of the way, I have the pleasure to present our first speaker, Mr. Chen Bainian from the ROS-Industrial Consortium Asia Pacific. He works with the Advanced Manufacturing and Technology Center of ROS-Industrial Asia Pacific and presents his work on quality assurance automation with industrial CI. Please, Mr. Bainian, the floor is yours.
Hi, good morning, everyone. Thanks for joining this year's ROS-Industrial Europe Conference. I'm Chen Bainian. I'm a development engineer in Advanced Remanufacturing and Technology Center under A-Star Singapore. We're also the Asia Pacific region's ROS-Industrial Consortium. Today, I would like to share with you about quality assurance automation with industrial CI. This talk will consist of 3 parts. First, I would like to give an overview on some of the goals for quality assurance work going on here in ROS-I Asia Pacific. Second, I will give a brief introduction on how to make use of industrial CI for your quality assurance pipeline, and also a preview on some of the new features that we're adding in to industrial CI. Lastly, our future plans and development roadmap. Okay, the aim of our quality assurance work package is to ensure quality for software packages that we and our partners develop here in Asia Pacific. In this work package, we're collecting best practices and provide information about useful tools and their configurations. We also aim to improve automated testing framework to reduce the effort needed to achieve and maintaining high levels of software quality. Lastly, through aligning within the ROS industrial community, we will also like to provide a standard with acceptance criteria to evaluate whether packages are of high quality, well documented, and is actively maintained. So here is a brief overview of the continuous integration workflow that we drafted. We also plan to create automation tools to judge on the results and tests that we have gathered and create a quality tier badge. I will elaborate on that later. Through community alignment, improvement on continuous integration and automation testing, and also establishing standardized quality level acceptance criteria, we can achieve automated industrial grade quality for ROS-based robotic software solution. So what is industrial CI? Okay, so now it comes to the introduction of industrial CI. So first question is what is industrial CI? It is a collection of scripts that help with deploying ROS-powered packages in continuous integration. Just like ROS is technically not an OS, industrial CI is actually not a hosted continuous integration service by itself, but rely on other continuous integration cloud service platform. It supports Linux as the OS platform and various architectures, including ARM. It also supports all of the active ROS-I and ROS-II distribution, as well as some of the end-of-life ones. For ROS-I, you can choose to use all of the available builder tools, and for ROS-II, it supports COCOM. It also works well on a variety of CI services, including Travis CI, GitLab CI, GitHub Action, Bitbucket CI, and much more through your own customization. So why do you want to use industrial CI? Well, first, compared to other like CI tools. So first of all, it was developed by ROS-Industrial, which is us, which is going to be good. Okay, joking aside, however, it is also superior due to its ease of use, supporting both ROS-I and ROS-II. It's easily configurable. It works seamlessly with private and unreleased packages. It is also widely used across ROS-Industrial Asia, Europe, and Americas. Of course, for the release packages, ROS Build Farm is also great. Okay, so we have also identified some of the limitations. For example, it lacks support of code coverage, dynamic analysis, which is in our previous pipeline that we draft out, and also available in ROS Build Farm. Unlike ROS Build Farm, which is hosted by Open Robotics, Industrial CI primarily relies on shared runner resources provided by other cloud CI services like Travis, GitLab, and GitHub Action. The result of this is that there is a runtime limit or runtime credit restraint for these hosted runners based on your building plan. However, nowadays with GitLab and GitHub Actions actually providing options for you to set up your own locally hosted runners, this problem is much easier to resolve than before. Lastly, due to the nature of shell scripting, Industrial CI currently still doesn't support Mac OS and Windows. To demonstrate the ease of use, you can actually set up a source testing pipeline in just about 10 minutes. Here is an example in Travis. Writing a simple config file like this will do the job. You can also specify which ROS Debian download pool to test with for example, the first test will run with main and the second one will run with testing. After registration and logging in Travis, your pipeline will run automatically upon pushing or creating a pull request based on your configuration. It will produce a comprehensive log with drop-down list, which is good for debugging when something goes wrong. Provided the pipeline passed, you can also add in the build status badge. It also comes with all the perks that Travis CI provides. Similarly, in GitLab CI and GitHub Action, you can set up the pipeline. You can also make use of additional tools and features that GitLab provides, such as stages and registries. So let's go into detail on what is happening during a source test. First, your repository source code will be cloned inside the CI Docker or the VM run by the CI service. And then the before script specified by the CI will run next, and it will start up the ROS Docker inside the CI Docker. Having a Docker within a CI Docker or VM will provide you certain level of abstraction, which is also why Industrial CI can easily work with different CI services. Next, on the orange box here, if you have upstream dependencies that needs to be downloaded or built beforehand, you can configure it such that you can configure it and Industrial CI will build this automatically for you. Industrial CI, when it tries to build a target or upstream or downstream packages, you will first install the target dependencies with the help of ROS-Deb. And then you will build the target. Then you will run the tests for the target. You can also specify downstream packages that depends on the current repository to ensure that the changes you made doesn't affect other packages that depends on it. One good example is actually the Tesseract packages developed by Zhoulai. So there are also notable features inside Industrial CI that are very useful. You can run the pipeline locally, so it will help with debugging because you don't have to push and commit and push to run the pipeline each time. It works in private repositories. You can run custom Docker ROS Docker images to shorten the build time. It can also build with C cache to improve building speed after the first build, particularly for large C++ projects. It can also check if there is any API breaks through comparison with the previous branch, commit, or tag. Also, it can run customized pre or post-process commands within each action represented in the previous diagram. And it can reuse Docker images to speed up the next build. However, this feature is actually in the process of upgrading. In light of some of the shortcomings, we are actually in the process of fixing some of them. These changes are almost ready and will be supported in the very near future, hopefully this year. First is the official support on code coverage. Now we can combine the coverage report from C++ and Python packages and upload them to various coverage reporting services. As we all know, coverage data helps identify what are the features that are not included in the testing process so that we don't need to write redundant tests. And at the same time, this will make sure that the APIs and features doesn't get broken. With code coverage reporting services, you can see a comprehensive web coverage report as I show here. This will show you what are the lines that are covered or not covered and how many times they are covered. You can also show you the coverage information during a pull request to see exactly how the newly introduced changes affect your coverage. Soon, in Industrial CI, you can run these tests simply by specifying the name of the coverage reporting service that you want to upload to. We now support CodeCov and coveralls on all platforms and for both ROS-I and ROS-II. We intend to support Codacy and GitLab in the very near future. The coverage files will also be exposed, so you can save them as artifacts or upload them to other coverage reporting services of your choice. So the next improvement that we have made on Industrial CI, which will is the official support for dynamic analysis. In the past, sanitizer tests can actually be easily run through a number of custom commands and configuration in both CMake and the Docker run option. Now we have we're going to support it officially in the pipeline. I have also attached here some additional tools that you can easily implement in your own pipeline to run additional tests and checks. The first link, thanks to the wonderful work by Levi from Swery, it is a collection of CMake macros that shortens the time for you to configure certain tests in a CMake package. These scripts can be used both in ROS-I, ROS-II, or even pure CMake packages. They're also very well tested in the Tesseract project. The second link is a collection of static analysis wrappers for ROS-II, including this package includes command line tools that you can use just to check a certain file, or CMake macros that you can incorporate during CMake or build and testing processes. It is also the default testing tool in ROS-II. Okay, up to the next part, we'll talk about some of the future plans and some of the things you can expect from our work package. First, after my implementation of the code coverage inside Industrial CI, I realized that the coverage tools currently in ROS is good, but not good enough. We have wonderful tools that, which are LCOV result and coverage py result. However, it doesn't generate a combined coverage report file. So in the future, we will try to combine them together to finally have a one-stop solution for code coverage in ROS. We will also improve the documentation for setting up quality pipeline. We will collect information on what are the tools that are commonly used and their common configuration, and also a step-by-step guide on how to improve your packages to conform with a certain Rep 2004 quality level. So another big plan that we are actively doing is that we would like to provide these cute quality badges. We intend to use REP 2004 as the criteria for providing these quality badges. However, we also understand that REP 2004 is intentionally generic so that the maintainers and developers are not tied down into using only one specific tool for meeting certain criteria. We currently envision it to be a hosted service that is easily deployable and highly customizable. I have actually listed down some examples here, like Codacy, Code Climate, SonarQube, and GitLab. Jenkins also have its own. However, these services doesn't meet all of the criteria and sometimes is tied down by one specific tool. Here is the proposed architecture that we have. First of all, based on the quality declaration, the hosted service will either test the criteria automatically or submit for review. For the ones that can be checked by continuous integration, tests and coverage results will be uploaded as artifacts for further quality determination. Since some of the requirements are also highly organizational, we propose a GitHub application to gather some of the information of the repository in order to test automatically. After the criteria are met and the ones needed for review are done, the quality level will be updated and will provide a quality badge. We can also in the future have bots to comment on pull request or elsewhere as well. In the next part, we have listed down some of the detailed policies within REP 2004 that we can automatically test it. So for versioning policy, we can test for those declared semantic versioning scheme with the help of some of the API backwards compatibility tools that we currently have in industrial CI. For change control process, a lot of them can be configured inside GitHub, so we can use a GitHub application to check whether those criteria are met. For documentation, features and API documentation might need review, while others can actually be automated. For software testing, everything can be automated. However, a wide variety of tools needs to be supported or included. And we intend to support test results from both industrial CI and ROS build form. For dependencies, we can just reference the dependent repository quality badge. However, for non-ROS dependencies, review is definitely needed. For platform support, all of them can be automated with the help of ROS build form and industrial CI. For security, for those who are using REP 2006 as vulnerable disclosure policy, we can test if it exists. However, we actually need to find more tests to be included for the security of the software. So here is our roadmap on the development. We intend to bring full implementation out next year, and we'll expand capability and increase adoption and support, hopefully in the future. Okay, that's all for my presentation. So here is some special acknowledgement. Thanks for Martínez, who is also the industrial CI maintainer, who helps me review and improve some of the code coverage features that I'm adding to industrial CI. Also, thanks Rafael and Alexander, who helps testing testing the code coverage features with a wide variety of packages. And also thanks Eric DeGeneres, Alex, and Gary, who is from the ARTC team here in ROS-Industrial Asia Pacific. And that's all for my presentation. Yeah, I will pass on to Kyle on the Q&A.
Okay, thank you very much for this interesting presentation. So we have quite a bit of time for questions. That's very nice. And I would start with one which came into my mind when I listened to the presentation. You said you're currently only supporting Linux. Are there any technical reasons for that, or do you plan to actually extend to other platforms?
Thanks. So for the support on Linux, it is mainly bound to industrial CI. It's mainly written in shell. So as you know, of course, there are certain support for shell in Windows. However, it is not very convenient to do a lot of things in Windows with shell. So we intend to test the current setup in Mac OS, and for Windows, we're actually thinking about still thinking about how we can bring support to it. Maybe a scaled down version.
Okay. There's actually a question from the audience, which I'm read out. Does anyone have experience with using industrial CI and GitHub Actions for private repositories with private dependencies? Is there an example configuration or tutorial available you're aware of?
So, okay, first of all, thanks for your questions. And yes, there is, we actually know people who use industrial CI for private deployment with private dependencies. Actually, if you look at the industrial CI current documentation, there is a guide on how you use it for GitLab CI. So yes. However, as I mentioned before, we're currently also trying to revamp the documentation so that we'll also provide you a more step-by-step guide on how you can set up in your own system.
Okay, thanks.
Sorry, just to add on that, primarily for Travis, it works for private repository. However, for dependencies, there is still to be tested. However, in GitLab, we know that it works pretty well. Yeah.
Mm-hmm. Okay. There doesn't seem to be more questions from the audience. So basically, just a reminder also for the audience: if you have questions, please post these using the Swapcard questions service so that we can discuss them maybe also later in the discussion round, which we'll have after the second round of presentations. So I'm not sure if we should wait out the time until we start with the next presentation. I would actually suggest that we move on with the next presentation. We have next two speakers, which are Mr. Zhoulai and Francisco Martínez from the IT University of Copenhagen. They are part of the ROS-I team at the University of Copenhagen, and they present their experience with semi-automated fuzzy testing of ROS components. I think Mr. Zhoulai is starting, so please, Mr. Zhoulai, we are waiting your presentation.
Hello, everyone. Thank you. It's been a difficult time, and I appreciate having this opportunity to present our work here. And this is a joint work with Francisco. I'm an assistant professor at the IT University of Copenhagen, and I have the great opportunity to work with an excellent student, Francisco. He will be another presenter for this talk. So we are going to talk about our experiences with testing ROS components using a technique called fuzzing, which is quite popular now. So our team from the IT University of Copenhagen, we are actually 3 people, and me and Francisco, and we have Andre on our team. We have a common goal, that is to find an automated solution for testing robotic operating system efficiently. By automated, I mean really our ideal would be to have a kind of a push button, that you push a button and you get some tested results. So I'm going to present how we try to achieve this. This presentation has two parts. I'm going to present the method part, and Francisco will share with us about our tool development and a demo with Technalia robotic operating system packages. So I'll start with fuzzing. It's a technique that has been there for a while, since actually 1989. People do experiments with pure random testing. At that time, there were Unix utilities that have been found to be quite buggy by simply using pure random testing. Actually, if we put pure random testing, just generate random inputs, and we were able to crash 1/4 of the Unix utilities. This is not the case today, of course, because of the development of the random testing. So fuzzing actually is pure random testing. Fuzzing, one moment, I got some, start my video, sorry. Excuse me, my video was not started. So fuzzing was testing with pure random testing, but in addition to that, it's placed with some feedback from the pure random testing. I'm going to explain this shortly. And the fuzzing is something that has been used by big companies like Microsoft and Google for finding a lot of bugs these days. And in this work, we are going to use fuzzing as a black box. That is, we don't want to really go to the inside of the fuzzing. We just use it as a third-party tool for testing robotic operating system components. There are two kinds of models that we are going to work with. One is the publisher-subscriber architecture. Another one is the client-server architecture. So how we do that? So first of all, how does fuzzing works? Fuzzing works with two components, two main components. One is the input of the fuzzing is a fuzz driver. The fuzz driver is a program that runs the software under test, and the fuzz driver also accepts external inputs to do that. And the kind of inputs can also generate some code coverage with the fuzzing tool. The kind of code coverage will be observed and be the input for the input generator. The code coverage can help the input generator to improve the input that we used in our previous input corpus. So that's a feedback loop here. We have the input that goes to the fuzz driver, and the fuzz driver runs the software under test. And we get some code coverage here, or maybe some other kind of behavior of the program that is used by the input generator to produce better inputs. And all this is done automatically. The input generator here use some existing mutational algorithm or evolutional algorithm to find better inputs. The thing we are using here, the fuzzing here, has been there, as I've just mentioned, has been there for quite many years. We want to use it as a black box. Now, how do we do that? Okay. So we first apply fuzzing techniques for the publisher and subscriber architecture, meaning that we want to test the ROS subscribers here. Our target is actually ROS subscriber, but we write ourselves the fuzz driver, that is the ROS publisher. We write the publisher because the publisher invokes the subscriber. So the publisher can be used as a fuzz driver. from the fuzzing perspective. As long as we have generated a fuzz ROS publisher, that is the fuzz driver, and it involves the ROS subscriber, then we can run the fuzzing backend to find inputs for the ROS publisher and test ROS subscribers here. In this way, we are able to find the inputs that may potentially crash the ROS subscriber. Another scenario is the server-client architecture. Here, the software under test is the ROS server. And we are interested in testing, in finding bugs in ROS servers. To do that, we only need to write the ROS client, that is the fuzz driver here. As long as we have the ROS client that runs the ROS server, and the ROS client also takes input from the outside, from the input corpus, then we are able to run the fuzzing backend to find bugs in ROS server. So again, we want to use all this kind of fuzzing technique as a black box. It's, our next presenter, Francisco, will give a demo on this. So, okay. You may wonder, not yet, you may wonder how we can tell the right and the wrong in this testing procedure. Actually, to tell right and wrong is a very difficult challenge. We are going to use the sanitizers to do this. And sanitizer is also presented by our previous presenter. But here I'm going to give some details about it. For example, on the left-hand side, we have a piece of code like x equals y divided by z. And what the sanitizer do is to inject some kind of assertions here to assert that z should not be 0. So the program on the left is transformed to program on the right. That is a program with assertions. And this program, once it runs, it can automatically detect whether the input, the z, can be 0. If z is 0, the crash, it will be a crash here. But there will be not such a crash on the left-hand side, supposing that z is a floating point number, for example. So sanitizer, again, is a black box technique we can use. It is an existing compiler flag in GCC and also in CCLAN. It is first developed by Google, and it is now widely used. I'm going to give a short demonstration on the sanitizers, because this is really important for our approach, at least in the future. So before doing that, just to give a summary on this, sanitizers inject assertions automatically, like assertions, for example, division by 0, and we just discussed here. It also injects assertions about array should be not go out of the bounds, or there should not be any pointers that be used after it is freed, used after free. So now I'm going to give a short demo on the sanitizers to show that it can actually help us to find the bugs automatically. It's a component in our approach. So I suppose you can all see my screen now. So I have let's see the source code. I have a very simple source code.
Sorry, Zhoulai, I guess that you have to share screen again.
Okay. I have to share screen now. Can you see my screen now? Can you see my screen?
Yes, we can.
Okay, cool. So thank you, Paco. So now suppose we have a program like this, a C program that first have an array of array A that has 3 numbers, 0, 1, 2. The length of the array is 3, and then we want to print the value of the items in A, but we print A0, A1, and A2, and A3, we print 4 numbers. And this is an error of the array index out of the bound. But if we run it, if we suppose we use GCC, this GCC fuzz.c, fuzz compile it. Okay, it's a bit slow on my machine, not because of GCC, but because of my machine is really slow. I hope it finishes very soon. Oh. So shortly, you are going to see that this program, I don't know. Okay, cool. This program, if we run it, what's going to happen is that we have 0, 1, 2 printed correctly, but the last one, we got the wrong number, but we got it silently. We don't, as a programmer, we don't know if the program is wrong if we just run it, unless we know the expected results, right? So this is an error. It's kind of undefined behavior that can make our program totally unreliable. But suppose we just add, we do the same GCC, just add a compiler option called fsanitize equals to, it's called address sanitizer. We do the same. Okay, very quick. And let's run it again. Boom. The error is revealed. For example, there's a lot of debugging information saying that here, okay, there are memory access at some place that should not go there. Oh, okay, so here is an example that shows that for the original code, here, a very simple one, it actually injects some assertions here to make sure that the index I should not go out of the bound of the array A. So that's how we tell the right and the wrong using our technique here. Now, can you see my screen again? I suppose you can.
Yes.
Yes.
Thank you. So summary so far, we show that how we use the fuzzing techniques in our approach. The main thing is we need to generate the publisher and the client in order to test the subscriber and the services. And we can use fuzzing drivers. We can use fuzzing technique as black box. We apply existing techniques, including fuzzing and sanitizing as black boxes. By black boxes, it's like what I just show in the demonstration. It's like a compiler flag, or it's like a existing backend in the case of fuzzing. And this, we believe, is going to be a fully automated method for testing ROS components, including subscribers and services. Okay, now it's Paco is going to present us about the tool and a demo.
All right. So the second part of this talk is actually regarding the tool and the Technalia demo that we have gone through. So basically, we have a single tool aiming for 2 ROS versions. We have ROS-FUZZ, which is for ROS-I, and ROS-II fuzz, which is for ROS-II. They are used in order to fuzz C++ nodes, such as subscribers and servers, as Zhoulai has presented before. There are several characteristics that both of the tools share. For instance, one of them being that they just comprise one C++ file. Also, it's a non-invasive tool. It means that you don't have to change your source code in order to make it work. It is also efficient, as it's leveraging on many years' effort in fuzzing research and implementation. And it is also open source. Here you have the links, and you'll find them in the last slide as well. And finally, it is semi-automatic, but soon we have plans to do it fully automatic. We're going to demonstrate it with a package coming from Technalia, which is also part of the ROS-I. And as you can see here in the code, just to give you some idea, this package works with polygons, as its name indicates, and it has some heavy math computation on them. So we are just going to try to fuzz it. And here you can see the code as well. So how are we going to fuzz it? Well, the first step is building the code. And for that, we have to specify with a concrete flag that we want to change the compiler with which all the code is compiled. But don't worry, here we are not using any exotic compiler. In fact, as you can see here, we use AFL's compiler, which is just a wrapper around the regular GCC compiler. But as you can see also in the screen, in the slide, as highlighted with red rectangles, this compiler is going to take charge of instrumenting different locations on the code in order to be analyzed aftermath with the tool. Here you can see a recorded example of how we are doing it. So we are just sourcing the setup.bash file as in any ROS. And then we are starting ROS core in the background. And the next step now is going to be navigating to where the node executables are installed in our system once we build everything. So now we are entering, for instance, in one of them, which is the codal polygon offset. And as you can see there, we have two files. One of them is the executable, and the other one is our tool, the lib injector, which has been transformed into a system library. Now, in order for the tool to work, we are just creating one folder that is called inputs, and we are putting there a file which is called input0 with random data, as you can see there. The next step is setting one of the environment variables that the AFL tool needs, as we will see in the next slide. And I'll present what AFL is really shortly. So as you can see there, we are just putting some command that works on the input and on the codal polygon. And you can see there that there is, in red, that is telling us that the test case of input0 is hanging the program. Well, and why is it? If we try to do it manually to inject the file into the node, the codal polygon offset, you are going to see some errors there. And you can see on which are the last lines of the execution that our fuzzer is actually showing some messages showing that the task didn't complete successfully. So we have taken a look slightly how it works, but this is how our tool works behind the scenes. The basic procedure is basically installing AFL with sudo installing AFL basically. Then you have to copy our injector file into the ROS package. Follows linking the injector with ROS libraries in the CMake lists file, which should be less than 10 lines of code, and we provide templates for that. And finally, the only interesting bit is that you're responsible of implementing a missing part of code in the injector file, which is precisely the FUZZ driver, which allows communicating with your system. For that, we also provide some FUZZ driver primitives, DSL, that it's a domain-specific language in C++, which you can write in order to achieve that. And potentially, this should be less than 100 lines of code. Then just the remaining steps are just compiling the project and starting any node by linking it to the injector, as we have seen previously in the demo, and let the fuzzing begin. Fortunately for us, we have plans of full automation, which means that most of the steps that we have shown in the previous slide will be simplified by just installing our tool, and they will be handled out of the box. Once the tool is installed, it will just require compiling the project and starting any node by linking it to the injector. The important bit here about automation is that we reduce and we free the user from writing a fuzz driver manually. Here you can see some screenshot of AFL by Google, which is a fuzzing tool, which is used by our program and our tools, sorry. And as you can see here, the important bits are that on the left side, you can see how much it takes. In this case, it's just 41 seconds to find several crashes that you can see on the right side. And a crash is basically a smart generated input that has been able to crash our system under test. The same happens with the hangs, which are hanging our code. Once we run AFL, we're going to have some generated inputs, and we should distinguish two of them again, which are the crashes and the hangs on the left side. The crashes are here interesting, for instance, because you can see there that we have from ID 0 to ID 4, and those are all the different cases that AFL has been able to identify, which indeed crash our node under test. And those are really good because they allow us to detect bugs, and therefore we can solve them afterwards. Another tool that really works with our package, even though it's not completely required, is the LCOV, which, as shown also in the previous talk, is another way for measuring code coverage. In this case, we use it to visualize AFL's code coverage. As you can see on the left side, we have different directories, and all of them have like source files. And on the right side, you can see two headers, line coverage and functions. And those lines are indicating for each of them how much they have indeed of line coverage and function coverage. If, for instance, we take a look at some of them, for instance, this is one example on ROS, on a toy example, we will see that on the middle column, just next to the code, you will see some numbers. Those are the times that each of the following lines are executed. You can see the nested we go, the more difficult it is for the fuzzer to find them. But eventually all of them, all the paths should be explored, as AFL rely on smart algorithms to discover all those paths. Finally, let's talk about some limitations of our work and the intrinsic characteristics of fuzzing ROS itself. The first one is that fuzzing works much better with fast iterations, which means that testing components that take many time to process, such as components that involve GUIs, are difficult because one of the requirements for fuzzing is having systems that run many times per second. So we can benefit as much as possible from fuzzing tools. And finally, we have that sanitizers target low-level issues such as buffer overflow, and this contrasts with what we are expecting, which is finding high-level functional bugs that following this path could be missed. So we follow with some conclusions. So we have derived a method for automatically testing ROS servers and subscribers, or at least if it's not yet automatic, then it's going to be in the short term. And we have tested it on a Technalia ROS-I package. And here you have some of the links to the project. And this is us, Zhoulai Fu, Francisco Martínez, and Andrzej Wasowski. And here we have our emails. Thank you.
Okay, thank you for this nice presentation, Mr. Zhoulai and Francisco Martínez, and also for the detailed demonstrations. It was quite interesting. We have a little bit of time for 1 or 2 questions regarding this presentation before we go into the general discussion round. In the live chat, there is actually 1 question which I would like to save for the general discussion. So what I have 1 question actually, and you said that you want to extend the tool to be fully automated in the future. So what has actually prevented you from making it automatic in the beginning?
So that's a good question. And indeed, one of the main problems is that in order to achieve an automatic full fuzz driver, we need a way to actually know what are the systems that we're going to fuzz. In this case, we need to know what are the types of the messages that we are passing to our node. That can be either a server or a subscriber. We have the problem though that in ROS-2 at least, there is there's not an easy reflective way, which is a way to inspect the types in order to create automatically the messages that we require to feed into the node under test. That's the main reason, basically. But we are working on that, and we're going to kind of circumvent this problem, probably with some sort of code generation that is going to be soon available.
Okay, thanks. And that was one more question which I would have. And you said basically this fuzzing is mostly suited for fast iterating components. But is that really a problem when the component is running slowly, or is it more or less a question of parallelizing, running many copies of a component and distributing the fuzzing input to it? Is there something fundamental on the iteration behavior of a component?
Well, the good thing about having like fast iterations is that the fuzzing tool can decide quickly what is the best strategy, because it tries many times and then it decides whether to shift or not the current strategy. So if you have really slow systems, then of course you're going to benefit equally from the tool, but it's just simply going to be slower. But that's completely fine if, as you have mentioned, you benefit from parallel executions, and if you have like all the power to execute it many times, then it's fine.
Okay, thanks. So when there are no more questions from the audience, then I would suggest we move on to the general discussion. And so I would ask all speakers to turn on the camera and the microphone so that we can switch to gallery mode, or what it's called. That we are all basically all visible. And while this is technically set up, I would like to start actually with 1 question before, which goes to Mr. Bainian once about industrial CI, as there was 1 more question from the audience, and this is, how should dependencies be handled which use other ROS versions?
So by ROS dependencies from different ROS version, you mean like do you mean like you use kinetic packages with kinetic package with melodic with a melodic package together?
Yeah, basically the questioner asks here, so my package runs on melodic but depends on a package which runs only on noetic, and another which runs only on kinetic. To run this in Docker images. So basic question is how are you going to handle such mixed version stuff?
I think like so I think my first question back to probably back to the back to you is that we need to see what is actually your use case, whether you want this package from noetic to be ported, or you want this ported so that you can build on melodic, or if you need certain customized setup to get this package work together, even on your local PC. So if you can do it on your local PC, you can, with the full customization of industrial CI, it is very possible that you can also get it done on the CI pipeline. However, the thing about CI pipeline is that it doesn't provide you a solution that that is something that currently cannot run on your local PC. So maybe I need to know more about your use case in this. Yeah.
Okay, thanks for that answer. I hope it answers what question I wanted to know. So to get kickstarted with this roundtable discussion, I would actually pose one question to all of you and then continue with a question from the chat. How do you see the current use of testing in the wider ROS community? I mean, we're talking here about ROS-Industrial, but there's also the wider ROS community. Is automatic testing already an established practice, or do you think there's more advocating of systematic testing needed in the community? Well, let's start maybe with our first presenter, Mr. Bainian.
I think for automated testing is definitely widely. Of course, the automated testing, it depends on what kind of test you're running, but in general, for testing, is actually pretty prevalent across the ROS community. If you look at ROS2 navigation, there is a lot of unit testing there. Of course, for ROS navigation, as well as for Move It, and also a lot of the ROS core packages. Every day for the nightly build, they will run the test to ensure that the features is still there, as well as you will also monitor the code coverage. So I would say continuous integration and testing is actually very common for the open source community within ROS. Yeah.
Okay, maybe Ms. Zhoulai wants to add something
about automated testing. My point of
yes, and it's take up in the community basically.
Sorry, what was the question? Can you say again?
About testing and how it's used in the community, actually, in the real world.
I think the community still lacks a good fully automated method for achieve our long-term objective, that is to have this full automation. Because the current status of software testing is experts or software developers, they have to write tests themselves. So testing is something that can only be done by a very few kind of people. And then once the tests have been written, we have all these kind of automated testing infrastructure, like continuous integration by Bainian just mentioned, to run the test automatically. So the automation really happens at different levels here. One level is how to generate the tests. Another level is how to run the tests. And also another level is how to report the results of the tests. I think for the later two levels, how to run the tests and how to report the results, this have been already covered in the continuous integration. But what is lacking in the community, I think, is a method that can generate tests. And that is what we are trying to do here at IT University. We want to be able to generate the tests.
I think our speaker just froze. So let's move on to the next.
What? Sorry?
Hello.
Hello, what happens? Can you hear me?
Maybe we turn off our video a bit and to relieve the bandwidth a bit.
Yeah, can you hear me? Hello?
I think we just had a small technical glitch, so I got reconnected. Anyways, thanks to Mr. Zhoulai for his explanation. And I would move on then to the first question from the audience, from Victor Maroy, which was about the relation between testing for security and for actually correctness. Basically, as they wrote it, there's an intrinsic connection between quality and security. Both perform testing and many tools are shared. So in the speaker's view, what's required to bridge the gap between software quality and software security? Why don't we go the other way around now and start with Francesco if he wants to say something, and then
yeah, so basically the question was related with security in the ROS side, right?
yes, basically
Yeah.
how to gap the bridge, how to bridge the gap between testing for quality and testing for security. By the way, to other audience, please post your questions.
I'd say that they are intrinsically related, because if we aim for quality in software, we must be sure that there is like no security leaks. So basically talking about quality assurance and avoiding security issues in our code should be quite related topics to talk about. And actually the way that they are solved, as we have shown in our slides, there is like not a clear distinction between what quality means, at least security related, because once that you achieve some security at low level, you are also getting some level of confidence that you have good quality of your code.
Okay, thanks. Anyone, Mr. Bainian or Mr. Zhoulai, you want to add something?
I agree with what Francesco just mentioned. I also think that quality and security are two different aspects, but closely related aspects about software quality in general. Security focuses on what the software, one moment. Security, as we know, focuses on what the software should not do. And quality focuses on what the software should do. Well, both are very important. So when we do the software testing, from my opinion, there are two kinds of software testing. One is so-called unit testing. It's kind of a thing that Bainian just relies on. That to do the continuous integration to make sure that the software performs as it is expected, in an expected way. Another kind of testing, in my opinion, is the one that Francesco and we just presented, to use fuzzing. So basically, fuzzing is a kind of security testing tool. It tries to generate some special, maybe invalid inputs to crash the software. It tries to crash the software from the attacker perspective. So those are really two kinds of different lines of research and development, in my opinion. And yeah, I think I also think that a software, as Francesco mentioned, if a software is insecure, its quality is also compromised. So meaning that the low-level problem that is triggered by a security problem should also affect the high-level quality in the ROS. That's my opinion about it. Okay.
Okay, thanks. let's have a look at the poll results which we have been running. There were actually a bunch of polls posted. The first one was, do you use continuous integration and deployment for your developments? And actually 66% answered here yes. So that is probably not so surprising, also given the answer I got from my previous question to Mr. Bainian. And there was another question we asked it here. Do you know what fuzzing was about? And surprisingly, 64 actually said no. So maybe Francisco, does it surprise you that 64% of our audience answered no? We didn't know before what fuzzing was about.
Well, to be fair, I had no idea whether the result of this poll was going to be, but it kind of makes some sense because in some way, even though fuzzing is conceptually a really simple concept, still its use it's something that it's not completely widespread. So that's why we also thought important that by participating in this conference, also more people from the sector, at least if they are not going to use it, at least they are going to take some idea of what how it looks and basically how it works, and maybe they can consider in the future using it or other similar testing techniques. Yes.
Maybe it makes you happy that then there was also another question, which was, would you consider using fuzzing with ROS? And at least, and 77% actually said yes, they would consider that. So I guess you had some impact with your talk. If we want to start, yes.
Can I add something?
Yes.
In addition to what what Francisco just mentioned, I think the community here are not so aware of fuzzing, partly because our focus here has been on the quality aspect about ROS. In fact, fuzzing is extremely well known in the security for the security people. I remember when I work on research papers on security, like almost one half about them is about using fuzzing to find security bugs. So, from my opinion, it's that in ROS, our focus has been on the quality, but the security aspect has not yet been an important issue for us. Maybe it is because we want first to make ROS better before making it secure. We first want to ROS work as expected, make it work, and then we will have this opportunity to have this possibility to think about whether the code could be attacked by some malicious attackers. This is, I think, for now, our priority has been on quality instead of on security. Because security is all about attackers. So if we don't have attackers, we don't need to consider the security. But as long as we need to use the ROS, we need to consider the quality. That's my opinion. So security is so far a secondary priority for us. That's why fuzzing is not yet widely recognized.
I would like to pose a follow-up question on that. As you said, we're only focusing on quality and not so much on security. But can there actually quality, which also for me translates into functional safety, when there is no security? Maybe this is also has a lot to do with basically the word of industrial in ROS-Industrial, as in industrial applications, functional safety has a very important role basically you need to prove that the things work as expected if you want to get a CE marked, as you all know. So I would use this and ask maybe Mr. Bainian once more about when you talked about in continuous integration or industrial continuous integration, do you see that actually testing for quality, testing for functional safety, and for cybersecurity should be combined and can be combined in a pipeline? Or do you think this is not so much well suited for continuous integration and needs to be addressed in different means?
Thanks. So first of all, I think for a lot of the current use of continuous integration is mainly to test functionality. So of course, things needs to work. A lot of the things needs to work before we go ahead and improve its quality, and then also look deep into the security of the code aspects. So of course, these tests are actually highly these tools are open source and actually can be integrated inside a continuous integration pipeline. And as time goes on, we will definitely look into how to enable certain options on running fuzzing tests on the industrial CI. And yeah, so I think another thing is that a lot of the things related to quality and also of safety is actually the reason why we're here, because for the wider open source community, a lot of the focus is perhaps mainly on functionality, on algorithms to get certain features achieved. However, for the quality and the security aspects is relatively more of the deployment and industrial application side. So it is also very understandable that a lot of people here don't really know about fuzzing attacks, right? Okay, thanks. We're almost out of time, so I would like to ask one final question with emphasis on a short answer, maybe 20 seconds or so. If you have a wish for software quality, so what do you wish for software quality development in the next, let's say, 5 years? So please, your 20 seconds question, and this time we again start from the Mr. Zhoulai, and then Francesco, and then Mr. Bainian.
So your question was, could you repeat the question?
So if you have a one wish for software quality, take or up or whatever, what was that wish for what should happen with software quality in the next 5 years? A 20-second statement, please, at most.
One of my vision is that software testing can be fully automated, meaning that not only we run the test automatically, we can write the test automatically. So it's going to be a full automation. So half of the development time of the software development has been on testing. And one of my wishes is that this part can be reduced.
Okay, thanks. Francesco, your 20 seconds on a wish for software quality in the next 5 years.
Yes, so it basically builds on top of what Zhoulai has said. So automatization is really important, but I also think that approaching this kind of techniques to lay people, which are not worried maybe about this concern, is also important, because we raise awareness of that. And by making it automatically, then pushing a button is not a struggle, right? So if people are able to do things fast, which they don't require to build really complex systems, then they can benefit from really highly studied techniques and components for free, basically in their projects. thus improving significantly their quality.
Okay, thanks. And Bainian Chen, you 20 seconds on a wish for software quality in the next 5 years.
So I think for software quality, the first part, I think similar to the other two, is that is make it more ready to use and easy to use through documentation as well as assisting tools. Another thing is the automation of writing tests. I think for this part also last time in the quality work group that Debbie shared about how to make use of artificial machine learning to generate tests and also evaluate APIs. So in the next 5 years, I think for artificial intelligence will be a very hot topic, and it will be also very exciting to look at how these technologies can be applied in generating tests and interpreting code, and also improving the ease of use of setting up software quality pipeline. Yeah, that's my 2 cents.
Thanks. Then I want once more thank all the speakers for their presentations and this lively discussion. Unfortunately, we're out of time, so I wish you all a nice day. Again, many thanks for the contributions, and hopefully see you next year again live in person in Stuttgart.